Welcome to the Explainer. Look, if you're just starting out on your coding journey, or maybe you've been at it for a little bit but you're feeling totally stuck, you are in exactly the right place. Today I'm putting on my expert mentor hat. We're going to completely cut through the noise, skip the endless tutorial loops, and ignore the conflicting advice out there. Instead, I'm going to hand you the true, unvarnished playbook for becoming a top 1% software engineer. We're not doing quick fixes today. We are talking about building a world-class foundation from the ground up.
So let's just dive right into a massive paradigm shift. Average engineers learn syntax. Good engineers learn patterns. But elite engineers, they learn systems, trade-offs, and exactly how reality breaks their code. Seriously, if you only take one single thing away from this entire explainer, let it be this. As a beginner, it is so incredibly tempting to just memorize code like you're studying for a middle school spelling test. But trust me, that's a trap. We really need to shift your focus away from just memorizing syntax and get you thinking about real-world systems literally from day one.
All right, here's our roadmap for today's explainer. First, we'll hit the elite engineering mindset. Second, choosing your first language. Third, the foundations you cannot skip. Fourth, surviving beginner pitfalls. And finally, we'll wrap up with the ultimate mastery loop. This is exactly what you need to know before you write even one more line of code.
Okay, jumping into Section 1, the elite engineering mindset, specifically depth, breadth, and taste.
Before you even think about picking your tools, you absolutely have to adopt the mental models of an elite engineer. The absolute top engineers out there develop 3 dimensions of mastery, and they do it in parallel. First, there's depth. This means knowing why things work, not just how to make them work. You actually build this by reading other people's source code and banging your head against really hard debugging problems. Then there's breadth. That's connecting concepts across completely different domains by building full systems. And finally, my personal favorite, taste. Taste is knowing what not to build. It's recognizing which trade-offs actually matter in the real world. Most learners only ever build depth in super narrow areas, but as an elite engineer in training, you really need to be cultivating all 3.
Now here comes a little bit of tough love. 3 to 5. That is the number of years of consistent, highly focused effort it takes to reach a senior level of competence. We're going to completely dismantle that whole learn to code in 6 weeks myth right here, right now. Careers are decades long, and mastery, that's a 10,000-hour endeavor. But here's the good news. If you actually set your expectations to this 3 to 5 year timeline, you're not going to get discouraged when things get tough next week. You know you're playing the long game.
Moving right along to Section 2. Choosing your first language, paradigms over syntax.
Okay, choosing a language is definitely the #1 anxiety for beginners. But here's a little secret for you. Languages are really just vehicles. To show you what I mean, let's contrast 2 wildly different ones. On one hand, we've got TypeScript. It's a fantastic, versatile daily driver. It's absolutely incredible for the modern web, and it's super refactor friendly. It's essentially what you want to use to build everyday things. On the flip side, we have C++. Now, C++ offers maximum control and basically 0 runtime overhead, but it will absolutely punish beginners. I mean, we're talking manual memory management and undefined behaviors that will make you want to pull your hair out. Picking the right tool early prevents burnout. You really don't want to start with C++ unless you are exclusively aiming to build game engines or high-frequency trading systems straight out of the gate.
So, the whole point is getting yourself an actionable stock. For 99% of you who want to be top-tier generalists, here is your exact playbook. First, use TypeScript as your primary daily driver for both front-end and back-end web development. Second, pick up Python as your secondary language. It's literally the undisputed king of AI, scripting, and data. And finally, put Go or Rust on your radar for your systems language, but seriously, don't even touch them until year 3 or later. Just keep it simple and focused for now.
Let's hit Section 3. Foundations you cannot skip.
These foundations, they are the absolute bedrock of every single production system in the world. Beginners almost always make the huge mistake of treating data structures and algorithms as just, stuff you memorize to pass a whiteboard interview. But here's the reality. Hash maps, they power literally every cache and lookup table you will ever build. Trees, that's what databases and file systems are fundamentally built on. Graphs model social networks and complex dependencies. Heaps drive task schedulers. You don't just need to know how to write the code for HashMap. You need to understand that when you desperately need a lightning-fast lookup in a real app, a HashMap is exactly the tool you reach for.
And knowing those foundations is what actually solves real, incredibly expensive problems. When you get a frantic message at 2 a.m. that the database is slow, an average coder just starts guessing. But an elite engineer, they know it almost always means you're missing an index, which, by the way, goes right back to understanding trees, or you wrote a horribly inefficient n+1 query. That means you're asking the database 100 separate times for 100 items instead of just asking it once. You just can't optimize a database if the underlying primitives are a total mystery to you.
All right, Section 4, Surviving Beginner Pitfalls.
There are these dangerous, totally silent traps that will completely derail your progress and keep you stuck at the novice level forever if you aren't paying attention. Consider this your official survival guide. The very first pitfall is tutorial hell, that's watching without doing. The antidote? Go build something right now that isn't in any tutorial. The next trap is stack hopping. Jumping to a brand new language every 2 weeks just gives you super shallow knowledge everywhere. You have to pick one stack and stick with it for at least 12 months. Another massive progress killer is node deployments. Listen to me on this one. You haven't actually shipped anything if it's only running on your local machine. Deploy every single project every single time.
Let's really contrast these two paths. The average learner just passively consumes. They binge tutorials, they use simple print statements to try and find errors, and they leave their projects sitting perfectly safe on their own laptop. But the elite learner, they thrive on friction. They build without anyone holding their hand. They actually learn to use real debuggers to step through their code line by line, and they push their work to production where reality can actually test it.
And now our final section, Section 5, the ultimate mastery loop.
This right here is the single most critical execution loop you must internalize today. Knowledge without execution is literally just procrastination dressed up as study. While most people are just consuming content, elite engineers are out there executing this exact loop. You build, you break it, you debug it, you really understand why it broke, you refactor it, and you ship. You are going to run this exact loop on real problems with increasing difficulty for a solid 10 years. That is the true, unfiltered path to the top 1%.
And hey, notice that the entire middle of that loop is just debugging. Real software engineering is actually about 80% debugging and managing complexity. So you absolutely have to learn the senior debugging workflow. First, reproduce the bug reliably. If you can't reliably reproduce it, you can't fix it. Second, and please do this, read the error completely, all of it, including that giant scary stack trace. Third, bisect the search space to systematically narrow down exactly where the bug lives. And fourth, fire up a real debugger. It is time to stop guessing and start actually observing what your code is doing.
So let's bring this all together. What is it that truly separates the average from the elite? Average coders react to bugs. Elite engineers actively build systems that prevent them in the first place. Average coders optimize locally. Elites optimize globally. Average coders say, well, it works on my machine. Elite engineers actually care that it works in production for the actual real-world users. At the end of the day, your job isn't to write code. Software is actually a huge liability. More code just means more bugs. Your real job is to deliver outcomes and manage complexity. Engineering is all about the application of constraints, and reality is always the final judge. Code that works perfectly in your head but breaks in production is, well, broken code. So here's my challenge to you right now. Close this explainer. Step out of tutorial hell. What are you going to build and break and debug today? Get out there and start running your mastery loop. Thanks for learning with me, and I'll catch you in the next explainer.